Oh, okay. All right. So what we're going to do now is we're going to pick up with concentration. Last thing that we were talking about was what solubility, how do things dissolve, like how do we know if something's soluble, how it changes with temperature, the whole saturated, supersaturated, that whole thing. But now we're going to look at, now that we know what things do and don't dissolve, we're going to look at concentration, which is how we describe how much stuff is dissolved in your solution. So concentration is basically this right now. It is basically the amount of solute you have dissolved in your solvent. And we have different ways of measuring concentration for different reasons. So most people out there living your normal life, this right here is good enough. This, the qualitative. And if you can see, let me go like this here, guys. Do you see how that's like almost the word quality? Almost. It starts with the prefix the same as the word quality because it's basically a descriptive. It tells us quality. Like this. It tells us concentrated. It tells us dilute. It's like good, bad. It's good enough for normal people doing normal things like making Kool-Aid and lemonade. However, yeah, it is less good for things that you want to have measured precisely. So chemists being chemists want to measure things precisely. Also, doctors are going to want to have things measured precisely. I don't know, all kinds of people for like whatever reason. We need to have things measured quite well. And so if qualitative doesn't work, we move into this thing right here called quantitative. And if you see quant, it's like the prefix quantity tells us how much. Now this is telling us not how good or how bad, if it tastes good, if it tastes bad, if it's concentrated or dilute, but actually specifically exactly how much is dissolved in our solvent, exactly how much solute is in our solvent. Dig? And so we have molarity. That's like the chemist's version. We also have one other one. Here, let me go like this. I'm gonna do some on the fly editing. Look at me, all 21st century. We've got percent composition. Oh, wait a minute. It's gonna be percent mass or percent volume. Now this is what most people use, like percent mass, percent volume. For example, when you make a 10% bleach solution to sanitize everything, because you should, because it works, we use percent by volume because volume is how we measure liquid. It could be percent by mass if you're doing things on a scale and doing it by mass. That's how you do that. And then we have down here this last one. I'm pointing at the screen because you can see that parts per million. Now we use that particular kind of measurement for concentration is used for things that don't dissolve very much. Like the example I used in class was lead. Lead basically doesn't dissolve in water, except that it does, but it dissolves so little that it's almost imperceivable. Like it takes some pretty serious equipment to detect lead dissolved in water. However, that is enough to have major effects on our body. Or, for example, parts per million number of virus particles in a cough droplet that comes spraying out of your nose when you sneeze, to be topical and timely. Yeah, so parts per million we use to measure very, very, very small amounts. So let's just dig in here, guys. Let's go with what is molarity. Good thing is that equation that you're looking. I don't know, is it down there for you guys or there? I don't know. This equation right here. That molarity is. All these equations are on the back of your reference chart, and if you don't have one, I can shoot me a thing in the whatchamacallit and I'll shoot you a link to download and print out some if you want. So this is molarity, and this is what chemists use to measure concentration. Because you see right here, it is moles of solute, because chemists are making chemical reactions happen. So we need to know the number of moles of reactants we have to make sure that we are having that golden ratio that we need from the chemical equation to make it actually happen. And if you'll notice, it is in liters. Do you see that? Look, watch. I'm going to be super fancy fly. You see that? It is in liters. Bam! Super important. Red liters. Do not forget liters. If you see this right here, if you see that capital M, you must have liters. You have to. Ways that they will mess with you. Okay, now watch. There's a certain couple of ways they'll mess with you. Right here, where it says moles of solute, they might give you grams. But you know how to convert grams to moles. You're not scared. And the other thing they'll do down there is, like, see this right here, liters, right? They'll probably give you milliliters. And you know, just move the decimal place over 3 times and you're all good to go. So that's the equation for molarity. That's like the chemist's way of doing things. Now we go to parts per million. Parts per million is pretty simple. It is mass of solute, which is part, over the mass of solvent, which is like the whole thing. So it's part over whole times a million. Does that make sense? It's literally percent volume, only instead of this number right here, instead of that number being 100 to make a percent, we do it by a million because it's like a really, 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 really small, teeny little percent. So we call it parts per million. Kind of cut and dry. The only thing I want you to notice here is that here and then there we got grams, right? These two things are grams and then grams. So that's parts per million is basically a percent multiplied by a million instead of 100. Got me? Good. The next one is, oddly enough, it's going to be a percent mass. Oh, hey, that's Wilder. Percent mass, say hi, Wilder.
Hi.
There's people looking at you. So percent mass is, dude, it's part over whole, just like percent composition. Only in this time it's going to be the mass of the solute divided by the mass of solution. Now this is where they're going to trick you, so be careful. This is the mass of the entire solution, right? So if it's like 5 grams of blah blah is mixed with 20 grams of water, this down here, I'm pointing again, this down here, it's going to be like 15 if it was 5 and 10. Can't remember what I just said, but you know what I'm saying, right? So that's where they're going to trick you up on that. Down here it is where it says solution. It is the mass of the entire solution. Past you guys. I don't know what that is. Let's not look at that. So that's percent mass, and it's just part. It's like percent like I said, percent composition, part over whole times 100. Only it's mass. Okay, good. Oh, also that equation, back to your reference table. Next one is the percent volume. Now, percent volume, you might look at that equation and say to yourself, "Golly, that looks a lot like percent by mass." Only if you're looking here, they're using liters, like, you know, volume. So it's percent volume, like volume of the solute divided by the volume, again, of the whole solution. Okay, don't forget that it's the volume of the whole solution. Look, guys, seriously, listen. You see that? See that? Like, take that. This.
He called you cuckoo.
Remember that? Olive, please. Okay, so molarity, moles per liter, right? Pretty simple. The way they're going to mess with you with that is instead of giving you moles, they might give you grams. Instead of liters, they're going to give you milliliters. Okay. Then you got and then you have parts per million and percent composition. All three of these things are almost exactly alike. The only difference with parts per million is that you're multiplying it by a million instead of 100. Parts per a percent by mass, it's literally the mass of the solute divided by the mass of the entire thing. You're just doing a percentage by mass. And then percent volume down there, that is literally percent composition just with volume. So it's like the volume of your solute divided by the volume, in this case, the whole solution times 100. Are you good? You guys following me on this one? Okay, so what I think I might do, we've got like all these wonderful sample problems I'm going to walk you through. It's really not difficult. What's difficult is like just knowing what to put where. This is, you'll see it's really basic algebra. I mean, look at this equation. Like x equals a over b times 100. That's really all it is, right? Like percent volume is x, like a over b times 100. So I'm gonna cut this off here because that's it. That's all the notes we have for concentration. There's not a lot to it. It's just a matter of practicing and like knowing where to put your right variables and with what. Okay, so that's concentration. Sample problems in the next one. Yeah.